In this video, we're going to be talking about subcritical, supercritical, and ultra-supercritical boilers. The topic is a little bit complicated, so we're going to need to discuss some theory before we can actually talk about the boilers themselves. If you're like me, then sometimes when someone discusses theory, you sigh a little bit because you want to deal more with the practical side of engineering and less with the theory. However, I can tell you that if you understand the theory, the practical side of engineering becomes a lot easier as well. It's more difficult to understand the theory side than it is the practical side, a lot of the time, mostly because some of it's counterintuitive. There are three main reasons why the power generation industry is moving more and more towards supercritical and ultra-supercritical boilers. The first is improved efficiency. We can increase the pressures and temperatures that our boiler operates at, thus increasing the efficiency of the plant overall. In the past, a coal-fired power station may have had an efficiency of about 35–37%. Now we're moving more and more in the direction of 45%, and there are experiments taking place to push this efficiency even higher in the direction of 47–48, maybe even 50% or slightly above. This is mega important, and it lets you understand why the power generation industry is moving more and more to supercritical boilers and ultra-supercritical boilers. Without a steam drum, we can operate the boiler at a much higher pressure and achieve much higher temperatures. Why? Because when we manufacture a steam drum is manufactured from a flat metal plate. The plate's going to be quite thick to withstand the pressures at which it's going to operate. We take that flat metal plate and we roll it into the shape of a cylinder. So it begins to form the shape of a steam drum. But then we need to weld the two ends of the plate together in order to form a cylinder. If we take water and heat it up to 30 degrees Celsius at atmospheric pressure, it is then in a liquid phase or a liquid state. This could be a glass of water that you've got on the table in front of you as an example. If we heat the water further at atmospheric pressure, at some point it begins to boil around 100 degrees Celsius, and it will change then to a gaseous state, a gaseous phase. It will change to steam. The critical point is where liquid water and water in a gaseous state, in other words steam, have the same density and begin to have the same thermodynamic properties. It's no longer possible to differentiate between the gaseous and liquid phase of water. You'll know from your own experience in life when you're making a cup of tea that when you heat water up, it begins to boil and then we get steam. That doesn't happen at the critical point. There is no boiling